Hello everyone, welcome to our channel AskPrep. In today's series on 11th grade chemistry, we will be studying chapter 11, the P block elements, in detail. Let's start the video. Starting with general electronic configuration of P block elements, elements belonging to groups 13 to 18 of the periodic table are called P block elements. General electronic configuration, NS superscript to NP superscript 1, except for He. Group 13 elements, the boron family, outer electronic configuration, NS superscript to NP superscript 1. Atomic radii, the atomic and ionic radii of group 13 elements are smaller than the corresponding elements of alkali and alkaline earth metals. Reason, moving from left to right across a period, the effective nuclear charge increases, causing the outer electrons to be pulled more strongly towards the nucleus. This results in a decrease in atomic size. Moving down the group, both atomic and ionic radii are expected to increase due to the addition of a new electron shell with each succeeding element. Exception, the atomic radius of Ga is smaller than that of Ul due to the presence of poorly shielding 10d electrons in gallium. Next is ionization enthalpies. The first ionization enthalpies of the elements in group 13 are lower than those of elements in group 2 in the same period. Reason, the removal of a p electron is easier than the removal of an s electron. Therefore, the first ionization enthalpies, IH, of group 13 elements are lower compared to the corresponding elements in group 2. As we move down group 13 from B to Ul, the first ionization enthalpies, IH, decrease due to an increase in atomic size and screening effect, which outweigh the effect of increased nuclear charge. There is a discontinuity in the ionization enthalpy values between Ul and Ga, and between In and Tl, due to the inability of D and F electrons, which have a low screening effect, to compensate for the increase in nuclear charge. Electronegativity. Down the group, electronegativity first decreases from B to Ul and then increases. This is due to discrepancies in the atomic size of the elements. Physical properties. Boron has a high melting point due to its strong crystalline lattice. The rest of the members of this family have low melting points. 2. Boron is extremely hard, black in color, and non-metallic in nature. 3. The other members of this family are soft metals with low melting points and high electrical conductivity. Chemical properties, oxidation states. The first two elements, boron and aluminum, show only the +3 oxidation state in their compounds. However, the other elements in this group, gallium, indium, and thallium, also exhibit the +1 oxidation state in addition to the +3 oxidation state, i.e., they show variable oxidation states. As we move down the group, the stability of the +3 oxidation state decreases, while that of the +1 oxidation state progressively increases. Group 14 elements, the carbon family. Group 14 includes carbon, C, silicon, C, germanium, Ge, tin, Sn, and lead, Pb. General electronic configuration of the carbon family is Ns superscript to Np superscript 2. Next is carbon. Carbon is the 17th most abundant element by weight in the Earth's crust. It is available as coal, graphite, and diamond. In its combined state, it is present in metal carbonates, hydrocarbons, and carbon dioxide gas, 0.03% in the air. 2. Naturally occurring carbon contains two stable isotopes, superscript 1 superscript 2c and superscript 1 superscript 3c. A third isotope, superscript 1c, is radioactive, with a half-life of 5,770 years, and is used for radiocarbon dating. Next is group 14 elements, the carbon family. Covalent radius. The covalent radius is expected to increase from C to C. From C to Pb, a small increase is observed due to the addition of a new energy shell with each succeeding element. However, the increase in covalent radii from C to Pb is small due to the ineffective shielding of the valence electrons by intervening d and f orbitals. Ionization enthalpy. The first ionization enthalpies of group 14 elements are higher than those of the corresponding group 13 elements. Reason, the effective nuclear charge increases, and the size of the atoms becomes smaller. First ionization enthalpy decreases down the group from carbon to tin. The decrease is sharp from carbon to silicon, but there is a slight increase in the first ionization enthalpy of lead compared to that of tin. Electronegativity. Group 14 elements are smaller in size compared to group 13 elements, so they are slightly more electronegative. From C to Pb, the electronegativity is almost the same. The small increase in ionization enthalpy from Sn to Pb is due to the increased nuclear charge outweighing the shielding effect of the additional 4f and 5d electrons. Physical properties I. All the elements of group 14 are solids. They are less metallic than group 13 elements. 2. Melting points, MP, and boiling points, BP, of group 14 elements are generally high. Chemical properties. Carbon and silicon mostly exhibit a +4 oxidation state. Germanium forms stable compounds in the +4 state and only a few in the +2 state. Tin forms compounds in both oxidation states, while lead forms stable compounds in the +2 state and compounds in the +4 state are strong oxidizing agents. Anomalous behavior of carbon. Carbon differs from the rest of its family members. The main reasons for its anomalous behavior are I. Exceptionally small atomic and ionic size. 2. Higher ionization enthalpy. 3. Absence of d orbitals in the valence shell. 4. Higher electronegativity. Since carbon has only s and p orbitals, it can accommodate only 4 pairs of electrons, while other members can expand their covalence due to the presence of d orbitals. Carbon can form pi-pi multiple bonds with itself and other atoms with small size and high electronegativity. Allotropes of carbon. The property of an element to exist in 2 or more forms with different physical properties but identical chemical properties is called allotropy, and the different forms are called allotropes. Carbon exists in 2 allotropic forms. I. Crystalline. 2. Amorphous. Crystalline forms of carbon. Diamond. In diamond, each carbon atom undergoes sp superscript 3 hybridization. Each carbon atom is tetrahedrally linked to 4 other carbon atoms. The C bond length is 154 pm. Properties. 1. It is the hardest substance on Earth. 2. It is used as an abrasive for sharpening hard tools, making dyes, and in the manufacture of tungsten filaments. Graphite. In graphite, carbon is sp superscript 2 hybridized. Graphite has a 2-dimensional sheet-like structure consisting of hexagonal rings fused together. The layers are held by van der Waals forces, and the distance between 2 layers is 340 pm. Properties. I. Graphite conducts electricity along the sheets. 2. It is very soft and slippery. 3. Used as a dry lubricant in machines running at high temperatures, where oil cannot be used as a lubricant. Fullerenes. Fullerenes were discovered collectively by scientists E. Smalley, R. F. Curl, and H. W. Kroto. Preparation. Fullerenes are prepared by heating graphite in an electric arc in the presence of an inert gas such as helium or argon. The sooty material formed by the condensation of vaporized C small molecules consists mainly of C, with smaller quantities of C and traces of other fullerenes containing even numbers of carbon atoms, up to 350 or above. Properties. I. Fullerenes are covalent compounds and are soluble in organic solvents. 2. They form complexes with platinum. Amorphous allotropic forms of carbon. Coke. It is a grayish-black hard solid obtained by destructive distillation of coal. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exams.